In today's video, we're going to look at permutations and combinations and look at how we calculate these, what the difference is between them and the similarities, and then we're going to look at some examples and how to do this on a calculator. So to start with, I'm going to present you with two different problems, and they're going to look pretty similar in how you would think to calculate them, but I will show you which one's a permutation, which one's a combination, and then how you would actually go about calculating these and what the difference is. So first problem I'm going to look at, let's say that you have 5 people running a race. And I want to know in how many ways can I award first, second and third place, assuming that we didn't have any ties between people, etc. How many different ways can I award those 3 prizes amongst the 5 people? Okay. Okay. My next problem that I'm going to look at is, say that we have 5 people at this particular business and I need 3 of them to complete a job for me. In how many ways can I pick 3 people out of the 5 to do this job for me? Okay. What's the similarities? What's the differences here? Okay. In both cases, I start out with 5 people. And in both cases, I'm picking 3 out of the 5. What's the difference? The difference is that in my first problem here, I'm ordering those 3 people. So in this first problem, let's say that I chose 3 people, the first 3 people that came across the finish line, okay? They are my first, second and third place winners, okay? The first person that crossed the line is the first one, second is the second place and third is the third place, okay? So those 3 people are my 3 winners. But if those same 3 people cross the finish line first out of the 5, but in a different order, so instead now the person that was my first place came across second, and the person that was my second place came across third, and the person that was my third place came across first, that's a whole different combination that I've got here. So that actually counts towards a different way of awarding first, second and third place. Okay, so in my first example, I can have the same 3 people cross the line but in a different order, and then that's going to count as another way of awarding first, second and third place. Okay. In my second example, I start with the 5 people like we did before, and I'm picking 3 of them. But this time, I would have to pick a different set of 3 people out of my 5 in order for it to count as another way of solving the problem. Okay, so for example, if I start with 5 people, A, B, C, D and E. Okay. In my first example, let's say that A came first, B came second and C came third. Well, in that order, A, B, C, that is one particular solution to my problem. Okay? But let's say now, instead of that being the case, I had A came first, then C came second, and then B came third. Well, that's another solution to my problem. Okay, that's another way of awarding first, second, and third place. Even though it's the same three people, because it's in a different order, it counts towards my solution. But in my second problem, okay, let's say that I am asked to choose 3 people out of the 5. And let's say I choose A, B, and C. Okay. Well, I've chosen those 3 people now. It doesn't matter if I choose A, B, then C, or if I choose A, C, then B, or if I choose B, C, then A. I'm still picking the same 3 people. The order of them doesn't matter in that case. It just counts all of them as one solution, no matter what order I pick them in. Okay? So that's the difference between these two problems. In my first problem, the order matters. And in my second problem here, the order doesn't matter. No matter what order I take my 3 people in my second problem, it's still going to count as one of my ways, regardless of which way that I put them. Okay. One of these is a permutation, one of these is a combination. Turns out that the first one, where the order does matter, is called a permutation. When the order doesn't matter, it's a combination. Okay. So what I'm going to do is give you the 2 different definitions. So a permutation of n objects taken R at a time. So in my example, I started with 5 objects taking 3 at a time. It's an arrangement of R of the n objects in a specific order. Okay. A combination of n objects taken R at a time. So again, in our example, we started with 5 people and we were picking 3 to do a certain job. Okay. It's a selection of R objects from the n with order disregarded. So the order does not matter when we look at combinations, but when we look at permutations, it does matter. So in our examples here, in my first example, I'm looking at how many permutations do I have. In my second example, I'm asking how many combinations do I have. There are formulas in order to figure this out, to make it easier so that you don't have to try and sit there and think of all possible permutations and combinations. Okay. The way that we actually write this for permutations is the number of permutations is written as a capital P of n objects where you choose R at a time. It's denoted as P open parentheses NR. So we're choosing R out of n objects and we're looking at permutations, so I use a P. And the way of calculating how many permutations there are of R objects out of n where our order does matter, because we're looking at permutations, is n factorial over n minus r factorial. Remember, a factorial is you start at that number and multiply it by every number below it, down to 1. Okay. Combination, so if I'm looking at how many combinations there are of R objects out of n, we denote it by CNR, and that is n factorial over r factorial multiplied by n minus r factorial. Okay. You're always going to end up with more permutations than combinations. You can see that by the formula, because we're taking, for our combinations formula, to see how many combinations there are, we're dividing our permutations formula by r factorial, which will make it smaller. Okay, so there will always be more permutations than combinations. That makes sense, because remember, when we came back to our examples at the start, okay, if I chose A, B, and C in my second example, that's just one combination. But I can take A, B, and C in different orders, and each one of those is a permutation for my first example. So I'm always going to have more permutations than combinations when I use the same N and R. Okay. Let's go ahead and do a couple examples. So here in my first example, I've got a board of directors has 12 members. In how many ways can 4 people be chosen to negotiate a merger? Okay, so in this case, I'm just picking 4 of my 12 people to do a job for me. It doesn't matter what the order of those 4 people, it doesn't matter what order they are picked in, none of that matters. I just want 4 distinct objects out of my 12. Okay, so that would be a combination, because the order in which they are picked does not matter. So I've got the number of combinations of 4 people out of 12. So we write that as combination, capital C, 12, 4. Using our combinations formula, n is 12, r is 4. So we're going to have 12 factorial over 4 factorial multiplied by 12 minus 4 factorial, which would be 8 factorial. I will show you how to do this on a calculator, and there is also a shortcut way of doing this as well. But for right now, when you go ahead and calculate that, if you know where it is on your calculator, you can go ahead and do it now. It's 495. But like I said, I will show you how to do this on a calculator at the end. In our next example, I've got a board of directors, has 12 members. And this time I'm asking, in how many ways can you choose 4 officers, president, vice president, treasurer, and secretary, out of those 12 members? Okay. This time we have an order. Okay. If I had 4 people, we'll call them again A, B, C, and D. Okay. And those 4 people were chosen as president, vice president, treasurer, and secretary. Okay. I could also choose the same 4 people, but in a different order. We could say that B was president, A was vice president, D was treasurer, and C was secretary. Okay, that is another permutation. I've taken the same 4 people, but in a different order, and it's now formed a different set of officers, because I have a different person as president, different person as vice president, etc. That's a new permutation, even though I've used the same 4 people. Okay, so because of that, we're looking at permutations here because the order of them matters, because each new order and each new set 4 people is going to form a new permutation. So I'm looking at the number of permutations of 4 people out of 12. So I've got P 12, 4, which if we go back to our formula is going to be n factorial over n minus r factorial. So it's 12 factorial over 8 factorial, which is 11,880 different ways that I can choose those 4 people out of 12 in specific orders. Okay. These were both similar problems again, like we had at the start, where I start out with 12 people and I'm picking 4 of them. But remember, in our second example here, the order of those 4 people mattered. In my first example, it didn't. Now I have this example which is very similar to the start. Okay, I have got 8 children running in a 100-meter race. In how many ways can first, second, and third place be awarded, assuming that there are no ties, exactly like we had in our first example? So again, because the order matters, I'm looking at permutations. Okay, and I'm starting out with 8 people. I'm picking 3 of them where the order of those 3 people matters, so I'm looking at permutations. So it's going to be n factorial over n minus r factorial, which is 8 factorial over 5 factorial, which is 336 ways. So the moral of the story here is whenever you get one of these problems, if the order of the people that you are choosing matters, we use permutations. If the order doesn't matter and you're just picking, let's say 4 random people or 3 random people in this case, but the order of them did not matter, we're looking at combinations. Okay. I'm going to go ahead and show you how to do all these factorials on the calculator, and also there is a shortcut for using permutations and combinations on the calculator as well, which will make this even easier. So on your calculator, whenever you do one of these problems, you can either do it using the formula, in which case you will need to use the factorial term. So whenever you need to do that, on your calculator on this TI-84, take the number that you want the factorial of. So in one of our examples, we were looking at 12 factorial, okay? If I wanted to write 12 factorial, type in the number 12 first, then go to math and go across to where it says probability and go down to option 4. There's an exclamation point. That is our factorial expression. So we've now got 12 factorial. If you click enter, it will come up with what 12 factorial is. You will then need to do some division there because we had n factorial over n minus r factorial. So you're going to do the same thing again. But anytime you need that factorial term, type in the number. So let's say I'm looking at 8 factorial. Type in the number 8, go to math, go across to probability and down to option 4, click enter and enter again. Then I can always do some division within this just by tapping on those numbers. There is an easier way to do this with regards to our permutations and combinations. Let's say one of our examples that we were looking at was taking our 12 board members and saying that we needed to select 4 of them out of the 12. One of them was looking at it in terms of permutations where the order mattered. The other one was looking at combinations where we were just picking 4 people out of the 12, but order did not matter. In order to do that, okay, let's say we're doing 12 where we have to pick 4 of them and we are looking at permutations. If we're looking at permutations, it's going to be this NPR that we find under math and probability, exactly where we found that factorial term. It's that second option down. But in order to use it, what you need to do is type in what the value of n is first. So whatever you've chosen for n, so in our example when we had 12 people and we were picking 4 of them, we put 12 first. Then we go to math, go across to probability and click NPR, okay, if we're looking at permutations. If you're looking at combinations, it's going to be our third one down. We'll do that in a second. But we're going to click that NPR and then whatever your R value is goes after it. So N goes before it, R goes after it, and you've got to find that NPR in your calculator under that math and probability menu. And click enter. And that is the same answer that we got when we used that formula with factorials in it. So this is a good check or another way of doing it. If instead we were doing that second example where we're looking at combinations, but we again start out with 12 people choosing 4, we're going to click 12, go to math, probability, down to our third option, and then R was 4. So N always goes first, R goes last, and we get the same answer that we got for that problem. So this is a great way to check, or it's another way to do the problem if I do not ask you specifically to use that formula.